first achieved the feat of landing a person on the moon in July 1969, more than 50 years ago. So if we had the technology back then to travel, land safely, and return, then why haven't we ever gone any further in space? It's the billion-dollar question, and one of the most enduring and controversial issues in modern science. After all, even though the Cold War was undoubtedly one reason for going to the moon in the first place, the inherent desire of humanity to expand and explore played a major part as well. That desire has seemingly been with us ever since we left Africa and decided to see the rest of the planet. Some scientists think this need to explore might even be hardwired into our DNA, as there's some evidence that a gene called the DRD47R gene is what shapes our daring curiosity and sense of adventure. Of course, the moon landing did bring about various other benefits and breakthroughs too, as is usually the case with any exploration mission. The learning of new information about our world, the creation of new technology, and the discovery of new materials. It all contributed toward our growing civilization. But has that same technological advancement now dulled that innate need to explore? In some ways, perhaps. But in others, we've never been closer to learning so much new stuff. Today, it can feel as though we're perpetually on the brink of a true paradigm shift, waiting for the next big change in our knowledge to happen. So what's really stopping us from exploring to other worlds again? The first question to ask is, what comes after the moon? Having already planted our flag in the lunar dust, where's the next frontier? Despite there being plenty of intriguing places in the solar system, our options are severely limited by their habitability. Our technology may have come a long way, but it's still not nearly enough to directly see all the other worlds even within our own solar system. Consider Venus. It's widely dubbed Earth's twin, but even there, we'd still die within seconds of exposure to it. Mercury is also quite close to Earth, relatively speaking to the rest of space, but it's so close to the Sun as well that it has almost zero atmosphere, and temperatures range from far below freezing to well above boiling. Therefore, as most of the other solar system planets are either gas or ice giants, without so much as a surface to stand on, that leaves us with Mars, the only real candidate for exploration that's being seriously considered right now by pretty much any and all space agency or company. But, as we all know, that much-promised human mission to Mars is taking a long time to actually happen. So, what's the holdup? Building and launching shuttles for human travels is 1. Dangerous, 2. Expensive, and 3. Rarely even an option, which is why most missions to anywhere in space use uncrewed spacecraft. The potential for danger is also one of the most often cited reasons to delay plans for crewed missions in the future. Although creating something of a catch-22, the delays are then one of the main reasons why crewed travels cost so much. And then the time it takes is in many ways out of our hands, as all launches to all objects, including Mars, are guided by the pattern and schedule of launch windows. Even a Martian launch can be described as rarely even an option, because of the way that the orbits work for our two planets. The movement of us and it mean that the truly ideal launch to Mars comes around only once every 15 years. Even the less ideal launch window comes just every 2 years. So space travel works within these constant deadlines, and until now, due to all manner of reasons, including budget and technology, it has variously missed them. A crewed Mars mission is continually put back to the next window and the next and the next, as predictions lengthen for when we might finally get there. Beyond those more traditional concerns, however, what's significant is that Mars, according to some, could be both the next and last destination that humans will ever attempt to physically explore. Once humans on Mars is accomplished, there's arguably no next target. On the simplest level, this plays a role in why we're taking so long to go to the Red Planet, since it's our only goal. If we had a longer list of genuine future candidates that we could genuinely get to, we might also have more incentive to start working through that list, but we don't. And so, at present, we're still faced with many of the same key technical difficulties, including how to build a ship that's large enough to sustain a crew for long enough to get them to Mars or anywhere else, but also a ship that's lightweight enough to even get off Earth in the first place. There are ideas towards a lunar launch pad or an orbital launch station, but those blueprints still haven't moved closer to practical reality. The questions that continually dog the likes of NASA, then, haven't disappeared and could in fact be growing louder. Is it possible? Will humans ever make the trip? And perhaps, most pessimistically of all, why bother? The psychological enormity of a proposed deep space mission covers more than just the ardent naysayer or the well-meaning scientist who's starting to lose hope, however. For decades now, there has been a real focus on the impact of the bodies, yes, but also on the minds of long-term astronauts, a concern that actually perhaps humanity isn't and won't ever be prepared for the mental strain. No matter where else in space we decided to go, the environment would be so drastically different to Earth's. Fundamentally, anywhere that's not here would be a place that humans haven't evolved to handle. The blue skies, fresh air, plants, minerals, and materials that make up our lives would be no more. And so, preparing for the psychological impact of that is essentially impossible. We know that each individual planet or moon would present its own specific challenges, from choking CO2 to blinding dust storms to crushing gravity. What we don't know and can't know until we get there are the precise levels of stress that could be caused by these conditions. Even if we could mitigate them with technology, how will humans react? There have been some experiments bidding to simulate what might happen, and often the results aren't encouraging. For example, in the 1960s, the US Navy led a mission called SEALAB-3 to test how well people could live in an underwater environment, but it went terribly. Throughout, it was plagued with stressful factors and faults, allegedly to the point that one person involved even began trying to sabotage the mission, meaning that others were forced to stand guard to prevent disaster. The exact circumstances surrounding SEALAB are unknown, and ironically, the mission was quietly closed down while the Apollo missions to the moon began to pick up steam. But we do know that one SEALAB diver did die. Looking back into space, we can understand and further suspect that living in such environments for a long time can weigh extremely heavily on the human mind. And in space, those performing the missions would be even further from the support they may need, like hospitals, psychiatrists, family and friends. Nevertheless, there are estimates today that humans could step foot on Mars sometime in the 2030s. There are plans being constructed for multi-year missions to a planet that's more than 30 million miles away at its closest approach. It remains to be seen whether by then we'll have devised a way to lessen the mental toll. But for now, that's the real reason why humans haven't explored beyond the moon